we're going to take a look at how to multiply polynomials. This is worksheet 5 on Unit 1. And we're going to mostly talk about distributive property. We will also be looking at problems that deal with base 10 number system. So you'll see some similarities with polynomials and how the base 10 number system works as it goes to addition, subtraction, multiplication, division. Now, for the first exercise, they're asking us to take this polynomial and figure out what it's going to be when x equals 10. So you would just go ahead and substitute in 10 anywhere you see an x. So now going ahead and taking the calculator and type that expression in. Okay. And again, you're going to type it in exactly as it looks. So you do 2 parentheses 10 to the third. Okay. And make sure you press the right cursor to get back down. But to kind of streamline this and speed it up a little bit, for this one right here, you're going to end up getting 2,534. The reason is because 10 to the third is 1,000, so this is 2,000. This would be 500. This one 3 times 10, 30. And the last one is just, again, 4. So when you're talking about exponents, really what you're talking about are different positions in the number system. Ones, tens, hundreds, thousands. So that's kind of the basis of how polynomials work. And now we're going to look at some questions dealing with multiplying polynomials. And we're going to use the array, or some people call it the box method, for finding out the products. So what we're going to do is, you can kind of see the product, or in this case, this area model they're using. That's pretty much the box method. And pretty much what you're going to do is you want to multiply each pairs of terms together. So people call it foiling sometimes, but you make sure you multiply everything together. So you got 3x and 2x. So like when we multiply, if you had something like 30 times 20, you're going to end up getting 600. So that means instead of 3x times 2x, you're going to have 6, and then you're going to have 2 x's. So just like 30 times 20 is 600, the amount of zeros, or in this case the amount of x's, increases. And then we have 3x times 5, which would be 15x. 2x times 2 is 4x. And then 5 times 2 is 10. And if you get negative numbers, you want to keep track of those in the boxes. But for this one right here, we can combine these two together. So as a final answer expression, we'd have 6x squared. 15 and 4, both positive, give you 19x. And then you have the 10. Now, this box method is a lot easier, a lot more helpful, especially with exercise 3. You could have, in this case, we have what we're going to call a 2 by 3. So we got 4x and 3. And then we got 2x squared minus 5x minus 3. So we need to fill every box with each product. So 2x squared and 4x, again, we increase the powers. 2 times 4 is 8, and x squared and x to the first would be x to the third. 4x times negative 5x would be negative 20x squared. Then we have 2 x's. Negative 3 and 4x would be negative 12x. And then going through the rest, you would get 6x squared, negative 15x, and then 3 times negative 3 would be negative 9. So you're looking for like terms. In this case, you have negative 15, negative 12, and you have 6x squared and negative 20x squared. So you want to combine those together. So you get 8x to the third minus 14x squared minus 27x minus 9. So this just gives you a way of organizing, which again can be very helpful, especially when you're dealing with this many terms. And then the last one we're going to look at in this case is exercise number 5. So they want us to find the product, and they give us 3 in this case. So we're going to have to do 2 at a time. I'm going to do a 2 by 2 box. We got x and negative 2, and then we got x and 4. So we got x squared minus 2x plus 4x, and then negative 8. So for this now I have x squared plus 2x, because I got these two that are like terms, minus 8. And I still have, now that I did these two, I still have this part here. So I have x squared plus 2x minus 8, and then I have the x minus 7. So now I got to do a 2 by 3. So I get x and negative 7 here, and then we got x squared plus 2x minus 8 there. So then again, you can go ahead and you can fill those in. And fill that one in on your own, show it to me, see what you come up with. But for going into B and C, it says for what 3 values of x are we going to have a value of 0? So I'm going to erase my little cross out here. Now to get 0, obviously in the parentheses you have to have a number that's opposite that. So there are 3 values of 0 that will work. X minus 2, so that means 2 is one of those values. Negative 4, and positive 7. Now you can find those values of 0 by graphing the expressions. So if you do x minus 2, x plus 4, and x minus 7. I'm going to make sure I'm in graph and table so I can look at both. Second graph. So what I'm looking for is I'm looking for my cursor on the x-axis. That would represent a 0. So we talked about negative 4, so I'd have negative 4, 0. We have 2, 0 on the bottom of the screen, and then if I scroll down, we end up with 7, 0. So those are the answers. Algebraically speaking, it's just because if I want it to equal 0, well, the opposite value would have to give me that to get that 0 out. Okay. And it says here to test one of these 3 values, all you really would have to do is you would have to just plug in one of those numbers, any of the 3, plug in one of these 3 numbers into the expression at the top. So if you plugged in 2's into all of these and wrote it into calculator, you should get an answer of 0. Alright? So hopefully that helped, and if you have any questions, please ask me in class.